So my name is not Ron Lieberman, it's Ron Leibman. but that's a common mistake. That's a common mistake because, I don't know, people autocomplete the R. There's no R in my name, but never mind that. So my name is Ron Leibman, and I work today in Facebook. And I came from startup companies, as you mentioned, and I think that the thing that I can bring to you from my experience is how things are different between Facebook and what we do in startups today. So I hope you enjoy it. So on the agenda, I will talk about problems, from my perspective, and how we deal with them in Facebook today, and how Facebook solves them. And I will dive into each component that we have in order to monitoring Facebook scale, and show some use cases. And hopefully we'll leave time for Q&A. So just before we begin, we had one day that we had, or a couple of days that we had, 1 billion active users, daily active users, and we are pretty stable on 1.4 billion active users, which is a lot. So edge cases are also a problem in Facebook scale because 1% of your traffic is 10 million people. It's a lot. So you need to think about every edge case, every corner case that you think you're going to encounter, it's going to be in high scale. So problems that we have today is all tools that are not accustomed to what we need to do. So for example, Nagios, which I personally like. I love Nagios, I admit. But it's only good for point-in-time monitoring. It's really difficult to do what happened in the last 2 hours in a fraction of 50% with our APIs. It's really difficult to do that. You can install plugins and extensions, but it's not that easy, and it doesn't scale. Another problem that we have is misusage of tools. Creating alerts from cron scripts, it's not a really good idea. Think about what happens when you have a tier or a cluster or a data center that you want to shut down for maintenance. You go on and you stop cron? Do you go ahead and SSH into each machine and comment out or comment it out in Chef for this specific cluster? I don't know, not a really good use case. And also, if you see in this example, it's really hard to know if something is wrong in the middle of the script. You need to check each pipe to see if something failed. Not the best case. Another problem that we have today is we are not treating metrics as first-class citizen. And what I mean by that is that today when we develop, there are a lot of people here from startups companies, and when you started your startup, you thought about, okay, I have this application data that I need to store, and I want to query it in a specific way and store it in a specific way with a specific engine. And you really thought about that. And as you go on and monitoring came as a need, you probably didn't think about, okay, how would I store my metrics? What kind of metrics do I have? Is it numbers? Is it logs? Is it something else? So this is another problem. And I think, in my opinion, the worst problem is the ops ownership. Monitoring your application is not the ownership. It does not supposed to be owned by the ops teams. Developers should have incentive to monitor their application. I think that as a developer, if you write code and you push it to production and you don't get that feedback of your impact of your code that you've done, you wrote some code, it took maybe a week, maybe a month, maybe a year, and you push it to production, and that's it, and you forget about it, and you move on to the next task. And so you feel kind of like a state machine with no state, like a stateless machine when you're always writing code and you don't get feedback from your work. So I would like to talk about our infrastructure and how we use monitoring and try to touch these points. So what you see here, it's a bunch of names which are meaningless to you. So I'll try to give some context. So the orange or yellowish squares are where we store most of our alerts or counters or logs. There are another systems that are in place, but because of time, I didn't put everything in. The red squares are components that react on alerts or create metrics or create alerts. The blue one at the top left is the UIs that we have, and the green one is the application itself, which we want to actually monitor. So let's start by talking about metrics, about ODS. So ODS is a operational data store. Its sole purpose is to store counters. Its only purpose. One can think about something similar like InfluxDB or maybe OpenTSDB or Graphite. Sorry, I apologize. So in Facebook, we have, for each entity in our infrastructure, which could be the data center itself, the cluster, the rack where the physical server is located, a port in a switch, an application, everything has an entity. And for each entity, you can store key value pairs of the counter that you want to monitor and its value, which will be a numerical one. So think about it that you can have counters for ports in a switch or very exotic entities. In my day-to-day use as a production engineer in Facebook, most of the time I am looking at data which is relevantly current, like from the last 24 hours. And because of that, we store most of our relevant data in memory, and all the other data we store in HBase on disks and not in memory in order to gain speed. So how do we add data? So you can add data from anywhere you'd like. There is an API for every imaginable language out there. But what we try to do is that each service owner inside Facebook can implement a very simple class or object, depending on the language. And it can export its metrics via some kind of an endpoint, which we call FB303 counters. And what that gives us is the opportunity to give the developers a way to export the counters, but not necessarily monitor them. So later on, we can decide what we want to monitor on. So eventually, as time goes by, developers and production engineers are starting to create metrics, and eventually, this becomes a lot of data, sometimes too much. And what we do in order to fix that is we do retention. So just to give you a bit of a context, so for example, after 2 weeks, the following 2 weeks will be 1 minute granularity for each counter. So if you store just any other metric, it will be the average of that metric. And if it's an aggregated one, for example, percentile 99 or I don't know, min, max, top n, it will be the same function again. But this is really sad because we want to have this data eventually. I mean, we are monitoring it. We are logging it. So we do, when we need to keep a specific behavior of the application, we are doing an aggregate of it. So for example, if you have a really important KPI or a metric that you want to store, you can do an aggregation of the P99 or P90 or the maximum of it or whatever you feel like and do an aggregation. We do aggregation by cluster, by the data center, by the custom, by something that you want as a developer as an aggregation. As a trade-off, if you want to have more granularity than what you are monitoring right now, you can physically we have some kind of a FB303 top applications. You can just point into one server and debug it on the fly and have the granularity that the service is actually counting itself, which is pretty nice. OK, so this is ODS. But eventually, when something happens, when you look at the graph and you see like a spike or you see an anomaly that looks strange to you, you want to dive in. And we do that by looking at logs. We see application logs like access logs for Nginx or Tomcat log for JStuff or any other logging that you do. And you want to get this data really, really fast, and you want the data to be relevant. So a lot of systems today can show you data before like a couple of days ago, or 1 day ago, or a couple of hours ago, which is also not too good. So for that, we introduced Cuba. So think about Cuba as an in-memory columnar-style data store with an SQL API. And the thing about this is that it is in memory. So all the data that you are logging from your application will go into in-memory of one of these servers. So you're probably thinking about, yeah, okay. He's like, okay, they're Facebook, they have a lot of servers, no problem, right? You just go on and scale as much as you like. But no, we have a really strict policy on the size and how long you can keep it. And in order to fix that, we are using sampling from the application itself and the client themselves. So if you are doing your sampling in an efficient manner and you keep the overall behavior of your service, you can find your trends along the way and get the data that you want eventually. So for example, one dashboard that we can see from Scuba is, I don't know, the left pane we cannot see here really good, but you can slice and dice the data as like any other SQL engine over there. You can see here that this is a week over week of metrics that are being created from the clients when they load Facebook. And you can see that when you look at week over week of your logs, you can see easily that something has happened. Maybe it's a good thing, maybe it's not a good thing, but it's really visible to see that something is wrong. Another thing I want to show is that this is, for example, the top 10 pages of Facebook for the last day. And the thing about this is that, I don't know if you can see this from here, but it's 63 milliseconds to get this graph. Even if you plot it on a different time series or whatever, or something else, 63 milliseconds is really, really fast for current data today. Another way to look at your data is by geographical location. So if you create your log and you have the country code from where the service is running and from where the clients are coming, you can know the geographical location and display it. And over here you can see this is bugs reported about photos over the last day comparing to next week. So in the red zones, you can see that people are really, really angry. And I think we were angry as well, if I can see it correctly. And in the US, for example, people are more satisfied. And you can, the thing here is that this is not like a stab to look at. You can click on a country and dive into that country and just group by everything that you like. So this is awesome. So which one should I use? So you should use both. And it really depends on what you want to use. I'm trying to think about it as if I want to know how much or how good the service is doing, I would report it to ODS. And if I want to see what exactly is going on right now, I would log it into Scuba as an informative log. So that was Scuba. Now I want to try to talk a bit about the alarms themselves that we create. So I think that everybody, I'm absolutely sure that everybody in this house has this idea of, has this scenario when you're coding, you're really productive, you're working on a production issue or whatever, and then somebody comes along and says, oh my God, fix the site, everything is broken, and all hell breaks loose. And the first thing that you want to know is what is going on, where's the service is located, how do you come up to this conclusion that something is wrong, and you need information. And for that, we create alarms. So alarms as an object in the system is not PagerDuty. It's not an email. It's not an IRC. It's not a Slack post. It's just an event. An event that's stating that something has happened in the infrastructure. And we try to make the alerts as much as informative as possible. So for example, you can see here that we have alarms documentation in the alarm itself. So you can say, if these alarms went off, you might suck at coding, but you might done something really, really bad, and you should fix it. So this is the alarm structure. So how do we create alerts? So all of our configurations are, I think, a large portion of our configuration are Python scripts that are compiled into JSONs in other systems that call configurator, if you've heard of it. So over here you can see that at the top over there, we are taking the modification file of the chef run that chef is writing to that file after each run, and we are reporting that to ODS. And from the bottom, we are creating a detector on this metric, and we are saying, take this metric, and for each minute, do the difference between the last minute. So this is actually meaning that if chef didn't run for 2 hours for 120 checks, then something is wrong. And notice that it doesn't say who gets this alarm, or if somebody will get this alarm. It just means that it will be created. So for example, if I compare this to a Nagios check, which will be, look at the file right now. If something has happened, then send an alert. And you cannot do this with Nagios easily because you need to save the state of what was the previous run of the file and compare it. So this is one example. The other example is using FB303 counters. So as I mentioned before, FB303 is a way to externalize your counters. And what we do here is we take all of the summaries and all of the P50 of our service in a 1 minute granularity, and we report this to ODS. And we create a detector really easily that we can say that if our percentage of the exceptions are greater than 10%, we can alert to create an alert upon that. And again, this doesn't mean that somebody will get this alert. It might be overlooked. So what I like here is that there is a really good decouple of how we create and how we store the counters and how we generate alerts and act upon them. Another example is not for a specific host, but something really like from a high-level perspective. So as a context, we have in Facebook a set of machines that are not inside Facebook and monitoring Facebook externally. You can think about Pingdom on steroids that we manage. And all of these hosts are reporting the data into Cuba, and we can query and create alerts on that. So for example, here we are taking all of the hosts that we have externally, and we are grouping them by the region. And for each region, we are applying an anomaly detection function. And the anomaly detection function takes the metric and transform it into a metric that we can, that is some kind of a threshold, some kind of a metric that says how much the service is behaving irregularly. And on that query, we can do some checking. So we check if it's below or above a specific metric, we alert upon this. So notice that this is a threshold check, but it's a check on anomaly detection. So it's pretty nice. Another thing I want to show you is that there is the description of the alarm inside of where the alarm is generated. So you can have the description and how to recover from this alarm, and if there are any other on-calls that are related, maybe you should ping them. And if you will get this alarm eventually to your phone or to your email or whatever, you will have all the necessary information to do something. This saves a lot of time. And one other note is I want to say is that this is Python code. developers should not have any excuse about saying, I don't know Nagios and I won't touch it. This is Python code, and if you cannot code Python code, then maybe you should not be a developer. So awesome. We have counters, we have logs, and we have alerts. So what do we do now? We don't necessarily want to get paged on them, right? Maybe we can automate this. I'm guessing that a lot of folks here are waking up at night, getting paged and saying, oh yeah, I need to go SSH into that server, restart it, take a look at the logs. This space is full. Where are the logs? Yada, yada, yada. For that, we have FBAR. FBAR is Facebook auto remediation system. And personally, I suggest all of you that when you go back home, try to think about how you can automate all of your stuff that you do day to day. And the reason I do that, I say that is because using FBAR, we are saving 136,000 human hours per day, which is a lot. Even for Facebook, it's a lot. And if you divide it for 3 rotations of engineers a day, it will be 17,000 engineers per day. And if you think about it, the next day, those 17,000 engineers won't come to work. So maybe you should double that number. Yeah, so FBAR is pretty cool. So FBAR is, in Facebook, we have API for absolutely everything. We have API for monitoring. We have API for controlling the data center components, the switches, the cluster ops that stays in the data center itself and replaces the disks and stuff like that. And we have an API for all of that. And FBAR, what is FBAR job is to get all of these APIs into one generic location and export it via a plugin API which you can write. And also, you can do more difficult things, and not only, oh, the service is down, then restart. You can do more complex scenarios. So a good scenario that we've done is kernel upgrades. So if you think about it, kernel upgrades it's a trivial task. You go, you install, you restart, boom, you're done. But not on production system, because you need to take down, to drain the server, to take all of the containers, all of the services down. You need to make sure you won't get paged on this server. Then you need to ship the RPM to install it, restart, wait for the restart, wait for the restart, wait for the restart. Maybe something is wrong. Okay, so I'll go ahead and create an on-call for the data center team. So complex things like that could also be automated in FBAR. And I think that this is saving a lot of time for us as well. So this is can you guys see that? Yeah? Okay. So this is, again, Python code, not something too fancy. But if you can see the remediate check, the remediate function, you can see that this is the algorithm that you use when you wake up, right? You do, okay, I'll check the service. If everything okay, PagerDuty off, good night. If not, okay, I'll try to restart it. Okay, maybe it's really stuck and the server is not running. So I'll escalate and I'll do something else. If restart worked, maybe the service is back, maybe the service is not. This piece of code can save all of you a lot of time. If you implement it right now, if you open your laptop and you do that, you will save yourself a lot of time to do that. Yeah, so FBAR is pretty cool. So we automated, we created alarms, we have ODS and Cuba metrics, and now we might need to get actual notification. But should we monitor and get notified about everything? Because the rationale here is that, okay, if I cannot automate this, this is a problem, and I need to treat it, right? So no, not everything. There are alerts that are not really that actionable for you, and you don't need to fix them, right? So if you have one server that dies out of thousands, then, or even from 100 servers, you don't really need to do that. So alarms that goes into your inbox, into your pager, into your whatever, should be actionable alerts. If you get an alert that you don't have something to do with that, you should not get it ever. This is a mistake. Please do not do that. You will burn out your people. Alert should be impactful. Maybe an alert is actionable, but you don't want to get paged on that because it's not that important. You can do it later. Or create an alert in a way that you won't notice it in the middle of the night. So personally, when I create an alert, I think I ask myself the question is, well, first of all, can I fix this? If so, then great. If not, let's automate this, because I don't want to get paged on that. And if I cannot automate this, is this actionable? And of course, should I wake somebody up in the middle of the night because of this? Just as a personal story for me, when I came to Facebook and I've been told that we are not getting paged on a single host failures. And I was like, yeah, right. But I mean, if one host goes down, it doesn't mean you need to treat it. I mean, if you do, you have another different problem in your organization. And the way we fix that is we do create alerts, but we are not getting a pager duty or a phone or an SMS. We create tasks in our systems. Or if you have a Slack channel, create a Slack alert that the server is down, please someone pick it up later when we have time. So we do want to do something with that, but not right now. There is a way to handle these kind of alerts. And also creating alerts is not that difficult. Again, Python code, if you can create an object in Python, you can create subscriptions. That's pretty easy. The nice thing here is that you can express exactly what kind of alerts you want to be notified about. And in a lot of tools today, this is not that easy. For example, Nagios, for example, you need to understand the whole hierarchy of the object inheritance if you do that. In Zabbix, you need to understand all of the rules that go by when you create an alert. It's not that good experience even for an ops, in my opinion, again. So I want to ask a question is, if you can raise your hand if you think you can write bugless code without any bugs in it, make sure that it goes to production, everything is good. Nobody? Yeah? All right, so this one is for you. Okay? You cannot do that. It's not humanly possible. And we know we have bugs today. It's a part of the system, and we should treat it as such. So because we know that we cannot create code without bugs, we probably cannot create alarms for everything that we want to. So if we cannot create alarms for everything that we want, how do we do that? How do we treat those problems? And by that, we use dashboard. Dashboarding is really, really good tool to pick up on stuff that you don't even know are existed. And everybody has these problems today in their organization. Everybody. So dashboards are good for that, to raise awareness for stuff that you're not thinking about them. It's good for making a case. Data wins arguments, we say. If somebody is arguing about something and you present a dashboard and says, look at this drop, this is fucked up, and the other guy cannot say anything about this, right? Because this is in front of the space. So one of the tools that we use is Cubism. So this looks like something like really off, but I'll try to explain. So each row here is a web tier that we have in Facebook, and the x-axis is time, and y is the metric itself, the counter. But you can see that for each row, every time that the counter goes to the upper bound, it gets rotated from the bottom, but with a darker color. So you can see that, is this working? Yeah? So you can see that over here in this part, there's a lot of traffic, probably daytime for where these servers are. And you can see that over time, data goes on, and the color gets lighter during the night. And if you can, I think it's you can see it over here that there is a problem in all of these tiers. Something has happened, and it correlates with everything. And alarm might not pick that because this is some anomaly that you don't thought about because we are humans. So this is a really good way to surface stuff that we didn't think about. Another look at Cubism is that by geographical location. So you can see that in the US, there's a lot of traffic, and in Asia, there are less, and in Europe, there's like ish between them. And you can see also the difference in the time zones, right? Because US time and Europe time is not the same time, so you won't get the same amount of traffic. And also here, you can see that something is wrong. I think that everybody can see that there is something wrong with Europe. There are some kind of a problem over here. There's like a really good drop, and then another one, and then a traffic shift, right? So even if you're not a PE, a production engineer, or operational oriented, you can clearly see that something is wrong in Europe. And for example, this is a DR, a traffic shift from one region in Europe to the other. Yeah. Another graph. This graph I want to illustrate is that when we report data to ODS, this is an ODS graph of a response time for a specific service. You can see that we can do aggregation and we can add counters and stuff into ODS, but you can do on the fly a mathematical equation on this data in time. So even if you didn't think that, oh, I'll need this P99 on this service, you can do that here. And for example, in this graph, you can see that what is interesting is that the average is like really, really high above the chart, and the P50 is like very, very stable, and P95 is below the average. So this probably is like, okay, so P95 is below the average, then maybe something is wrong in the P99. And one thing that I will do next is, okay, I will go ahead and take this P99 value and go into Cuba and see what exactly is going on. So this is like the flow of how I like to trouble stuff in Facebook. So every time you look at the graph and you see something that something is wrong, you always, like the first thing you do is you ask your peers, did you just restart this service? Did you just do this code push, this chef changes or whatever? You always try to blame somebody maybe, or maybe get information like, okay, is this really relevant? We have a system that calls Upstream, operational stream, which is very, very nice. Think about it is that you can create events that are not really failures, but more of a ops related. So deployment of a service, maintenance, experiment in Google. All right, they don't have experiment, but maybe pushing your APK to more percentage in Google Store, Play Store. And this could be automated via an API, and you can create them automatically, and then create annotation on dashboard to see what happens. And if this was an actual browser, I could hover on this line over there and see what actually happened and who created this alert, and maybe get more information from them. Really useful. So, מה היה לנו? Let's sum it up. So, one thing I want to deliver, one message is, treat your data wisely. Think about how you want to store it and what you want to store. Maybe you should not store everything because you're not capable, and if you do, store as much as you can, but think about what good storage engines will be good for your metrics and for your logs. Don't just default to the next best thing out there. It might not suit you. Before you alert, think about it. Think about, is this, maybe you can fix it and you don't need to fix the alert. Maybe the time that you create the alert will be the time that you need to fix the problem itself. Maybe you can automate this. How can you do that? Is it actionable? Do you need to do can you do something about that? And if not, how do you service the problem in another manner and not with an SMS or PagerDuty? And eventually, when you do decide to alert, should you wake somebody up because you do that. Think about this. So we are humans, and we cannot figure out all possibilities. We know that by now. Use dashboards in order to see beyond yourselves and understand things that you didn't see before that, and gain more insights from dashboards. As I said, data wins argument is really stuck in my head. And the last thought I want to leave you guys with is monitoring is not an ops job. We can fix this. I think this is one of the reasons that we change from SREs or operational to production engineers. Because when you go to a DevOps team or an operation team, as a developer, you automatically assume you have this bias, unconscious one, or maybe conscious one, that, oh, they are the operations, they do this shit, and I don't need to worry about that. And this is wrong, and we can fix this by producing better tools for developers, working with developers, and trying to convince them why they should care about this. And again, I want to go back to the point from earlier that as a developer, if I'm not getting a feedback from what I am doing, from the code that I'm pushing, from the changes that I'm doing, and I'm not getting that feedback, I will be burned out immediately. And probably after a year, I will leave the company and go to someplace else. And the problem is not in the company. The problem is with this relationship with the production system. So please keep this in mind. I think that's it. Just got a PagerDuty, by the way, yes. So there's a little bit of time for question if somebody wants. Yeah.
So I have a lot of questions, but let's start with the first one. So you mentioned the plugins for FBAR,
yeah,
and applying certain remediation policies.
Yeah.
If every developer can write their own policy, how do you make sure policies don't conflict or don't interfere with one another?
That's actually a good question. I think that people don't write policies for services that they don't own them. Because usually the on-calls team, the on-calls that do the on-call on the team, and the engineers on that team will care more about other people from their service, and they will create these alarms. I guess that you can, that by doing proper code reviews on your code, you can do that. But I don't think we have kind of a system in place right now.
So at some point you showed that you restart a service or a server automatically. That abstracts problems.
That's
in general, I mean. Obviously, it might be a solution because restart solves everything. But I'm wondering if you have 17,000 developers restarting services all over the place, how do you monitor that so that you don't create more?
That's a really good question. So we have ODS counters and scuba logs for FBAR itself as well. And you can, what actually people do is they monitor how Facebook is performing on their service. So if FBAR is restarting a half of the tier that you own right now, there is probably a problem without more than the resource itself, so you can get paid on that. And we're also introducing rate limiting on specific hosts, specific tiers, specific data centers, so FBAR won't go AI and take the whole site down.
Just last one.
You talked a lot about events.
Yes.
Where do you keep all those events? And what you haven't? You have events, and filtering and everything.
So we have the alarm system. I'll try to browse real quick. Yeah. So this one over here. Yeah, you don't see anything. This one. All of the alerts are over here. So every alert that you create that I've shown over here is created in a specific database for the alert itself, and other components can react upon that. For example, FBAR or any other subscription for creating alarms in PagerDuty, in email, in IRC, or whatever.
So thank you very much.
Thank you. יש לו עוד שאלה.